Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about plastic injection molding. So let's dive right into it. Now, first thing you have to understand, this is a specific tool specifically built for mass production, aka making boatload of parts. This is not something that you build or try to utilize or hire for rent when you are only building 1,000 or 10,000 parts. It is like if you are talking in millions, hundreds and thousands of them, then only you think about this. Now, it does have very high capital cost, as in like you compared to your building, this may cost same amount as buying a whole building. So this is a expensive equipment, but it does have one good thing, that it does make boatload of parts without degrading. As in, if you have a good equipment and you are maintaining it properly, you can make millions of parts from one machine. Like you bought this machine, of course electricity, plastic raw stock, you have to keep feeding it, but if you're maintaining it properly, you can easily get millions of parts of it. So it's a worthwhile investment, and it does have super high speed. Now this is another aspect that helps you in multiple ways. First, it helps you in what we call return on investment. Basically, if you are buying this machine is expensive, but you're not gonna charge $10 for one water bottle. You're gonna charge, like, let's say 5 cents or 3 cents, something like that. So that means you have to make boatload of them. Now the machine can survive for making boatload of them, and because it's fast, it can actually do it before it degrades too much. So fundamentally speaking, this is a very amazing tool for mass production, not for small scale, for mass production. Now, another aspect is plastic. You have to understand about this, that plastic is an umbrella term. It does not mean anything. When you say plastic, it does not mean anything. It's like saying hydrocarbon. But here's the vegetable oil is also hydrocarbon, and diesel in your car is also hydrocarbon. But you can get that point. They are very different. So that's the whole thing. Plastic is an umbrella term, and you have to select. You will never just like, I want to make chair out of plastic. They will be like, which blend? What exactly you want to do you want it to be food safe, or do you want it to degrade or not? Like, depending on that, you have to select it. And like, for example, one of the very popular one is polypropylene, as in this puppy is used for bottles. Like anytime you are seeing a bottle that is very thin walled, generally there's a very good chance this puppy was used. Then you have nylon, and then you have ABS. Now be mindful, ABS itself is another blend, so it's almost like every company will have its own blend, and anybody who is dealing with 3D printer knows how problematic that is. Like, you can build a printer, you can fine tune it for ABS. The moment you buy filament from another brand that is ABS, you're like, why the heck it's not working? You have the recipe change. So that's also another thing. And then you have to figure out, like, how the heck you're gonna manage it. For example, different strengths and weaknesses in each of these plastics. For example, polypropylene is very good in one way, it's very bad in another way. Some places you want something that is very frictionless, like nylon, you want to utilize that. Some places where you have a lot of moisture, you may not want nylon, you may want PVC. So that's the whole thing, because nylon absorbs too much liquid. Now again, you can design it that way that it can handle it, but do you want to? And that's all you have to figure out. Like, every plastic has some pros, some cons. I have provided a video down below that goes into detail about that, but be mindful, this is like an independent field of study that people have to spend years to understand that. Then you have multiple variables that you have to adjust. First, transparency. Do you want this puppy to be transparent? Yes or no? Strength. How strong you want it to be, because making it overly strong will also reduce your profit margin, and will actually make your product worse. Because let's say you are making a plastic chair, let's say you want to spend 3 kilograms of plastic, that's good on it. But what if you want to make it out of 13 kilogram? Again, yeah, the plastic is much more stronger. It can survive being in outdoor environment where UV light will break it down. It will still take decades to break, but here's the deal, it not only is now a biohazard because it's never going to degrade, it's very difficult for a person to move it place to place because it's now heavy. So you also have to balance this out. So you never want like GG strength. Does it need that GG strength? Yes, go for it. If it does not, don't wear. Like, one time use syringe. You do not want that puppy to be like very thick walled. Cost, because every Tom, Dick and Harry is like, I want everything, but can you afford it? Then you have surface finish, because many places you want smooth surface, but many places you don't. Like, for example, anything that requires grip, you want some different kind of plastic. For example, grip of a blade, like that's supposed to be grippy, it cannot be smooth. For other cases you want it to be smooth. So that's the whole thing. Another aspect is lifespan. How quickly do you want this puppy to degrade? Degrade in what circumstances? So all those things will affect what kind of blend that you are utilizing, what kind of plastic you are utilizing. And whenever you look about some things that say recycled plastic, at this stage, if you have this exact same formula, basically, let's say you are Coca-Cola company and you have Coca-Cola bottle for recycling, you can just like chop it up and put it here. Not every polymer blend will allow that. Most of them will allow you to directly recycle them as many times as you want. Then we come to injection part. Because it's an injection molding system, you have to understand the injection part. Now, injection is specifically made for pumping molten plastic into the mold. That's all it does. Now, the mold you are talking about is a negative mold. So basically, it will have a hollow space where you pump plastic in. So that's how it works. Now, we generally utilize what we call tapered screw with check valve. What does that mean? That simply means there is a screw. Now you may be like, okay, that just looks like a big ass screw. Yes, these are big. Like generally they can be like 1 meter to 3 meter long, like sometimes even bigger than that, or sometimes you will have two counter rotating one. So they are just screw. The benefit of that is like the outer diameter is exactly the same. That's absolutely true. However, the inner diameter, basically the shaft, is changing. So the reason for this is like you'd never want air to be trapped. So if you directly went from like taking a hopper, like you are taking the material from hopper and you directly started compressing it, you can trap air bubble into that. So you want to compact it, but you want air to escape. So you will have like enough space where it's vibrating, moving around, so air will slowly start to seep out of it, and then you slowly start to compress it. That will give you enough air time to like just leave rather than being trapped into it, and then you will start to compact it. Now why you are doing that? Well, you are doing it two things. You are compressing and heating it. So basically this compression itself will impart a lot of thermal energy into the plastic, so plastic will start becoming molten. And then on the outside of these pipes you will have a heater element. Basically you're gonna heat it from the outside. Utilizing both of them, you will have your finally molten plastic. Now why we want to go like this? Well, one benefit is that if you directly had a shaft where it's like, okay, there is a plastic, I'm just like using a hydraulic piston, I'm just gonna pump it. People used to do that, and if you buy a very small scale one, that's still what's used. But these are generally used when you are dealing with high volume, because if you are moving a lot of plastic and if you heat it up from the outside too much, you will have a scenario where the outside would be damaged because it was overheated and the core was still solid, because plastic is an insulator. Heating it evenly is very difficult. So that's why you want to have as few of a mass there as possible. So that's why it becomes smaller and smaller. So like you have only few millimeters of plastic. So heating is, if very thoroughly, you are heating it very thoroughly. And then if done correctly, it will allow you very even heating and void free flow. This is very critical aspect. That's why the injector has such a fancy valve design. So the idea is very simple. You just want plastic to be there, nothing else, no void. It's almost like a rocket turbo pump. If you send it void, it goes boom. Now here it won't go boom. You will have a plastic part that did not form because plastic flowed back. So that's the part of the injection. So this generally we utilize screw system with a flow design where you have a check ring. That's it. Like the ring, when you are pushing forward, it will make sure the plastic does not flow back. When you are pulling it, it will also make sure the plastic you do not create a suction force on it. So that's the whole point of this injection system. Then we come to the mold aspect. Now whenever you go to a company like Honda or whatever company have you, and you're like, okay, give me an injection molding machine, the injection molding machine is way too expensive. Now if you look at it, it's not that complicated. It's like a screw. Any machine shop with a good lathe, automated lathe, can easily do that. People do that. People have been doing it from 100 years. So why the heck is so expensive? Is the mold part of it. That's the expensive part. So you have to understand it. Like everything about plastic injection molding machine is like, take everything away. It's like any class 10 student can do that. The moment you talk about mold itself, yeah, now you're talking multi-billion-dollar industry. So it's very complex in terms of geometry. Basically you will never have any 90 degree. You'll be like, wait a minute, doesn't we make Legos out of it? Doesn't Lego have like very absolute dimension where it's like, no, it's 90 degree? So why I'm saying it's not 90 degree, its inside are always tapered. Now again, if the engineer did a job well and it had enough money for it, they will design in such a way that the taper angle would be 89 degrees. So it will look literally straight, unless you utilize a laser to find it. It will look absolutely straight. Now you do not want it straight simply because if your mold is deep, you will have a scenario where it's like you will rub on it and it's still molten plastic, so it will catch on it and you can destroy it. So generally you want taper so it pulls very properly, and it will also not create a vacuum issue where you are like, okay, I'm just gonna pull it. You're gonna create vacuum, and the voids on this system has to be designed in such a way that air can escape. That's another aspect. When you're trapping something there, you do not want like air to be coming from your mold, and mold has like opening and closing, so it has to be tight enough that plastic does not ooze out but still loose enough where air can escape. So these things you have to figure out. These are like very complex geometry, and it also needs a lot of cooling and polishing. For example, let's say you started the factory. It's like, okay, people, we're gonna make the more lot of Legos. Okay, you started it, your project started in the morning and you started the system. It's like 50 degrees Celsius. What happens if that 50 degrees Celsius starts to rise? These are big heavy steel things, so of course they can take a lot of energy before they actually heat up, but it will happen. By the time, let's say afternoon, your temperature will be going up to 80 or 90 degrees Celsius. Then that part will be out of dimension, and on top of that, because if the mold itself is not being cooled very quickly, the plastic part will take time, and when they will fall out of the mold, first assuming they will harden quickly enough, and if they are not, first that's the issue, they may not be hard enough, and if you fall, like it literally flop. Like you can literally have an injection mold system, the plastic chair came out and it just black, So that happens because it's not cooled enough. So cooling is a very critical aspect. So that's another aspect. You may think, okay, it's just a mold, I can like make a sand cast on that. No, you also have to figure out how to do internal plumbing on it so you can cool it efficiently. If you do not do that, your pumping speed will be much lower. So it's like, okay, plastic molded, now you are waiting, you're losing money while you are doing that. It's like, okay, is it cool enough? Is the cool enough? Yeah, okay. Psh. Now if you do it properly, it's like ting, done, ting, done, ting, done. That's why cooling is very important. And polish. The surface finish of these puppies are very critical, because not only the more surface area I have, the more probability of defects you can have. That's why you have to polish it. And any mold, generally if done correctly, they will be polished multiple times in their lifetime. So if let's say they have like 10,000, not 10,000 is too low, let's say 5 million uses, 5 million stamps, like patang patang 5 million times, every 1 million they will have to pull it out and polish it again. And draft is another aspect. It's like, can plastic flow into it? You can design something hululu if you want to, you can even make a mold into it, but would plastic flow into it? That's another aspect. It's like how much pressure you want to pump into it, because pressure is another aspect where you have to spend money on it. So if you design it properly, let's say you only need 500 tons of pressure to inject plastic, awesome. But let's say your design is a bit too complex, the flow rate is too bad, you need something that requires 2000 ton to pump. Again, there are molding machines that are that powerful, but again your cost went up. So you have to figure that part out, like how is the draft, how is the flow, and ejector also, because again these parts are cooling. So you have a metal that is like almost on a constant temperature, then you have a plastic that was molten because of the thermal mass of this puppy and the fact it has cooling, it shrank. It will get stuck with the material. So how do you pull it out? Simply because you will have injector pins. So basically your mold is like this, and then you're like pachang, you can literally see pins coming out of it. And look at any product that you see, if it's an open product, basically like tubs, buckets or stool, things of that nature, look at the underside. Generally they design in such a way that pins only affect the sides that customer will not affect to. Customer will basically not interact with, because if you are dealing with the side that customer will interact with, you have to make a very smooth injector pins. That will be very expensive. So all these, like all that money goes into the injector part. So basically till this point, everything you're talking about is like a basic hydraulic press. But the moment you talk about mold, that's a whole another level of engineering. Basically, how the heck Lego managed such a amazing thing? Simply because their molds are so great. Other companies have also tried it, but their molds were not that great. Like basically, Lego's a lot of money in Lego just goes into making sure the molds are accurate. Then we come to a bigger version of that. Like many times you see most of plastic products are generally single color. Let's say then you're talking about Xbox, like most of the plastic is just one color. It's like, so even if this part was forged, like made into a mold, it would be just one side. Here's deal. But we also have a bigger brother where you have two short molds. For example, if you are talking about a scenario where you need mixing of two materials for many reasons, you could have a desire to, hey, can I color it? Or you could have desire, hey, can I change the strength? For example, let's say you're making something that is airtight for vehicle use. Many things in your car has something like that. So they will have two hard plastics, but the border would be from soft plastic, so they create a gasket and they can seal it properly without needing another third party object. So it's like just two things clamped together, because the design was built in such a way it can become airtight without needing any third party components. So that's why you will use multi-shot material or two-shot system. Now be mindful when I'm talking about mixing two plastics. You have to, again, plastic is an umbrella term, and you have to make sure that they are compatible. So for example, let's say you want to make a keyboard that is like got your awesome, you want the fonts to be very transparent plastic, but it has to be a plastic, and the outer part would be another opaque plastic. Benefit, if you looked at any cheap basically backlit keyboard, you know for a fact that after using the paint wears off, it's just like you can't see anything. But if you want to have double shot system, you have to find a plastic that is compatible with the transparent and the opaque variant of that. So otherwise they will simply not stick together. They can delaminate, or they could even react with each other and mess up the outcome. So when, let's say, you buy a DeWalt system, you're like, dude, the grip looks too great, because it's plastic, it's directly molded into the system. So that's how you do that. Now it does come with consequences, so that's how you can figure out like how expensive the material is. You look at very cheap drill, like the cheapest drill you can find. You will not find like this sort of black stuff and other colors. You will always find one mold color is cheap. But look at any branded system like Bosch. Like Bosch, you will always find the green, and then you have a black plastic. DeWalt has like yellow and black plastic. Now again, this plastic can be changed depending on requirement. It could even have some variant of silicone or some variant of rubber that is compatible enough where it can be utilized in injection molding. So that's the whole point, and the reason why people want to do this is simply because they can achieve design and functionality. It's not just like, oh, it looks pretty. Many toothbrushes do that, where they have transparent core and just have like a stick inside it that's different color. That's a look only. But again, if it sells, it makes you profit. That's justifiable enough to invest in a expensive tool. And if you're talking about engineering pieces, generally they will have design and functionality. So not only it looks cool, it also acts comfortably. So people are like okay with that. So that's why you generally have a mold that is negative, as in like it will have bare minimum of or the material number 1, and then you'll have material number 2 that will be injected on top of material that. So it's basically like ink 1, ink 2, nothing fancy than that. But it does require you to have 2 steps of injection, meaning your cost goes down. So if you want to do let's say 3 injection system, yes, you can do that, but your cost will go up exponentially, and it will also slow down your system. So generally they utilize what we call rotating carousel system. So it's like 1 is negative, okay, then it will rotate, go to second mold, now the second is turning, and this time is first turn, then you pull it out, then it's like this whole complete piece is dropped, and then you rotate it like this. I provided a video down below, please do check it out. So these are 2 sort systems, and like if you ever wondered why the heck old computers were that expensive, one of the part was keyboards. I never realized like how expensive this keyboard basically caps are. Every letter requires this sort of 2 mold injection. So this was my presentation on basically injection molded plastic. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.